Hey everyone, welcome back to MLworks. In this video, we'll understand what is reinforcement learning and what are the certain terms that are related to reinforcement learning. And before we talk about what is reinforcement learning, the content for this video was taken from the free course provided by Hugging Face, which is DeepRL. So I would recommend you to watch that specific course, which is extensive, quite extensive, because there are a lot of tutorials which you can implement as well. So I would recommend you to get that free course and understand what is reinforcement learning. So this is purely notes from that specific course. So what is reinforcement learning? So consider, right, you have a machine learning model which learns from the data set and it has labels, and we learn it and we create a model, we train a model. Now what is reinforcement learning? Instead of you have a model, you have an agent, and instead of data set, what you have is an environment and a set of actions that you can take and the feedback that can be given for the set of actions. So what happens is you have an agent which looks at the environment, and based on the set of actions available to it, it performs actions in the environment. Now based on the certain kind of actions, you get the reward. Either the reward is positive or the negative. So the intention of agent is to get the positive reward. Now the reward that is given based on the action, it will learn whether the action was good or not. So while it is doing all this, there is no one to guide the agent which kind of action it has to take. So there is no supervision while doing this whole task. So if you want to understand in real terms, consider you have a small kid who has given a controller to a video game. Now it will, since the kid is playing for the first time, the kid won't know what kind of action it has to take. So what it will do is, once the game is on, it will try to take certain actions. And for the first action, consider in the step 2, it performs certain button and it gets the reward of a coin. And it performs the same action again and it gets killed and the game is over. Now, based on this set of actions and the rewards that it got, the kid will understand what kind of action it has to take and what it has to avoid. So that is what a basic RL process is all about. Now let's jump on to what exactly the RL process looks like, theoretically. So RL process is nothing but a loop of certain set of steps. These steps include understanding the state and then considering the set of actions that you can take on that state and then get a reward for that action and then move on to the next state. Now consider, right, the agent receives the state S0 from the environment. It could be kind of a first frame from the game you are playing. Now based on that environment, that is S0, the agent takes an action A0 and moves to the right. The environment is shifted by one frame and it is S1 state. And the environment gives some reward R1 to the agent, if not dead. And the agent means if the reward is positive, you get +1. That's it. This is the whole loop that happens when you're trying to understand the environment, take actions, and then how you move to the next set of state based on that action with the reward, positive or negative. So consider, right, if you see in this right hand side, you have an agent, and you take certain actions. In this case, there are 4 directions that is there. And that game, in that environment, you move forward and you move to the next state. And based on that next state, you also get a reward while you are doing that action. So it keeps in a continuous loop actually. That's the whole process of RL. Now, the whole point or the goal of an agent in RL is to maximize the cumulative awards, awards or rewards, and it's called as expected return. And there is something called as reward hypothesis, which is the central idea for reinforcement learning. And the key idea of that reward hypothesis is to maximize the expected return. So you have to ensure you take set of actions which keeps giving you positive rewards. When you keep getting the positive rewards, the agents will be in its best behavior. So this can be done only when it takes very good actions which will maximize the rewards, cumulative rewards. So the whole thing, right, this whole oral process is also called Markov decision process, which basically means, okay, whatever the action it takes, it is depending on the current state, not on the previous set of history of actions it has taken. It is only based on the current set of action it has taken in the previous step. Okay, it's not the previous set of actions, only the previous step or the previous action. Okay, it is based on that the decision is taken. That is the Markov property of RL process. Now, one of the thing to understand about RL is the observation and state space. Okay, so it is the information, okay, from given to an agent. Okay, it could be for consider, right? If you are playing a video game, it will be the frame, or if you are trading a stock, it could be value of a stock. Okay, when we are talking about state space or observation space, state space means, okay, it is the complete description. The agent has the information about the whole environment. Okay, and for instance, you are playing chess. Okay, there are 8x8 box present inside that chess in a system. Okay, you can capable of performing set of actions on it. Okay, so here the agent is aware of the whole space that is available to it. When it comes to observation space, consider you are playing a video game like Super Mario. Okay, so every frame there is certain set of actions that you can take. Okay, it is only partially observable from the user point or the agent point. It cannot go ahead and look into the whole video game. Okay, it can only take into consideration the one frame that is of the video game present. Okay, so this is the difference between state space and observation space, in which one you have the whole space available to you, in other you have only partial information available to you for taking decisions. This is very important for taking decisions and what you can do in that environment actually. Yeah. So next is the action space. We previously talked about observation or state space. Now is the action space. So action space is nothing but the set of possible actions that you can take in an environment. The actions can come from either it is a discrete set of actions you can take, or it is a continuous action, continuous space, or so the action can come from discrete or continuous space. I mean, okay, what is a discrete and continuous space? So discrete space, okay, nothing but consider the same example of Super Mario. Okay, so the kind of actions that you can take in Super Mario is only 4 or 5 actions. You can either jump, you can move forward, you can crouch, or you can move back. Okay, these are a set of actions. Only 4 to 5 actions that are possible in the discrete space of action. Okay, when it comes to continuous space of action, you can take infinite number of possible actions. Okay, for consider you have self-driving car, simulation or agent. Okay, where the car can go anywhere. It can move by 1 degree this side on the left or the right. It can jump, it can fall down, anything can happen. Okay, it can do anything. So there is the action space is unlimited in this case. When it comes to discrete, only finite set of actions that can be done. The example is same. One is Super Mario, the other is self-driving car. Now let's understand the most important or the most fundamental component of RL, which is rewards and discounting. Reward is nothing but the feedback mechanism, as I said earlier, and this feedback will help us to take the decision whether it is good or not, the action that was taken was good or bad. Okay, so the whole idea, once you are done with what the whole system of RL process, what you do is you get the rewards like R, cumulative reward at each time step. So it is nothing but capital R, which is RT plus 1, RT plus 2, and RT plus 3, and RT plus 4. So these are the for each time step what is the reward that is getting generated for the agent. Now it is nothing but it is the cumulative sum of all the rewards is the final reward, cumulative reward. Now how it will look like? So at time 0, okay, so which is K, and you will get RT plus 1. When K is equal to 2, which is RT plus 2, and finally, okay, this is what for every action at each time step you will get a reward, and it all combined together to get a cumulative reward. Now let's understand rewards and discounting, how all the actions are not capable of getting the same set of rewards. Okay, what do I mean by that, right? So in the previous slide we saw we are giving reward. Okay, let me go back. We are giving this reward. Okay, So where we are under the assumption that all the rewards are equal. Okay, but some rewards will be more important than other rewards. Okay, in reality, let's understand, right? For example, you have a game of what a mouse and a cat, and where the mouse is trying to get the cheese and the cat is trying to kill the mouse. Okay, now in this scenario, if you see this board on the right hand side, the mouse is it has nearby rewards of some cheese, and if you look at the cat, there are some rewards of cheese present near it. Okay, which are like quite much more rewards. Actually, there are multiple cheese in each block, and there is only single cheese in each of the nearest block nearest the mouse. Okay, so in this case, some rewards, for example, in this case, right, some rewards are that come sooner, which are nearer to the mouse, are more likely to happen. These rewards you will be able to get easily. Okay, and some rewards which are here, which are difficult to get, because the more closer the mouse goes to these rewards, there are better chances of getting eaten by cat. Okay, so consider this whole scenario where the little mouse is the agent. Okay, and the cheese is the reward that you get, and cat is the opponent to escape from, and each of these two opponent and the agent is capable of moving one tile at a time. Okay, so the cheese near the mouse, which is these single cheeses that is present here, they are more probable of getting eaten by the mouse than the cheese that is present near the cat, because those are difficult, because the more closer it gets, the more dangerous it becomes for the mouse to get eaten by the cat. So consequently, the reward near the cat, okay, it's even if it is bigger, though there are like multiple cheese blocks are present inside this one. Okay, the rewards that you will get are like discounted. It's not really sure that you will get this reward. Okay, because there are very good chances that you will get eaten by the mouse. So that's what the reward that you get while doing this. It will be a discounted reward, and the reward that you get, it might not be discounted. You will get the full reward. So let's understand that part. So updating the rewards with discounting. So what will happen, right? The discount is nothing but we discount the rewards that we give to the mouse in this case. So we define the discount rate called gamma. Okay, gamma is one of the parameter which will discount the reward that you get. Okay, it must be between 0 to 1, and most of the time it is between 0.95 to 0.99. So the larger the gamma, the smaller the discount. Okay, so what it means, right? This means our agent cares more about the long-term reward. Okay, larger gamma means smaller the discount. Smaller discount means you will get this good amount of reward at the end. Actually, even for the for the actions which will take in the future, right? For that also you'll get good reward. Okay, because the larger the gamma, smaller the discount, and the reward will exponentially increase. Okay, because if you see this equation here, r of tau rt plus 1, gamma rt plus 2, then gamma square rt plus 3. So these things will happen in future, right? Rt plus 3 is the next time step, which are into the future, and you are performing square and cube, and then fourth of the power and everything. So the increase in this one reward, overall reward. Okay, for the longer actions, for the long-term actions or rewards. Okay. So when it comes to, on the other hand, right, the smaller the gamma, the bigger the discount. Okay, so you will be discounting too much of the reward for the long future actions that you take. Okay, by that what I mean is, so by the time you will reach this specific location. Okay, the gamma is, if it is small, I guess, right, if it is small, the bigger the discount. The discount means you will be getting smaller value of reward, because you are not sure that you will be able to live or not, because you will get, there's a good chance of getting eaten by the cat. Okay, so on the other hand, the smaller the gamma, the bigger the discount. This means our agent cares more about the short-term reward. So all the rewards that are nearby, which is the single cheese that is present near the mouse, there are very good amount of reward you will get for that. Okay, then each reward will be discounted by the gamma to the exponent of the time step, which I described here. Okay, as the time step increases, the cat gets closer to us. Okay, that's what I meant. So as it gets closer, the reward are very less, because there is a good chance that you will get eaten by the cat. Okay, so this is the overall equation. So all the rewards are not equal, okay, for every action you take. Okay, so there will be rewards which are smaller, which are discounted, and some rewards which are not discounted or discounted slightly. Okay, so we have to understand that part as well. So with that, I'll be concluding this video. Okay, so I think we have understood what is an RL is, what is the RL process looks like, which is state, action, reward, and next state. And then there is observation space, and there is state space, there is action space. Action space is nothing but the set of possible actions that you can take in an environment, and observation and state space is nothing but the amount of environment that is available to you for that environment. Okay, so that is that. And then there is rewards and discounting. Not all rewards are equal. Some rewards are discounted, some rewards are not discounted much. Okay, so with that, thank you for watching and see you in the next video. Thanks.